doing systems of equations. The first thing we're going to do is a little bit of Algebra 1 review, okay? You've done this before. We're going to solve systems of equations today. We're going to do some that we've done before. We're going to use elimination first. Now remember, elimination works this way. First of all, you need to make sure that your numbers with the correct variables are aligned. So I need all my x's. I need all my y's. I need the equal signs to be aligned. And then the numbers, the constants, those are just by themselves. And remember, when we eliminate, we are going to add down. Okay? We're going to add down. So we want to eliminate by having the positive of a number and the negative of a number, because that is going to give us 0. All right? So make sure you understand that we're going to add down when we do this. All right, here we go. Let's try one. So the first thing I'm looking for is, are these numbers the same and opposite? I need the same number but opposite. They are not, and y is not either. So now I need to pick a number that I can multiply by everything. So I want to multiply everything here by what? What do I need to multiply 9 by to get negative 18? Well, I need to multiply it by 2. Well, I remember, I want different signs, so I'm not going to multiply it by negative 2. So let's see what we have now. I have my first equation, of which I did nothing to it. My second equation, I have to multiply every single thing here. Remember that? 2x times 2 gives me 4x. 9y times 2 gives me positive 18y. And negative 15 times 2 is negative 30. Now you'll see right here in the middle, I have the same number, but opposite. So when I add these two things up, I'm going to get, those will be eliminated. Negative 8, 4, that is a negative 4x. I just combine like terms. Negative 18y and positive 18y, that is eliminated. You shall be eliminated. 6 plus negative 30 is negative 24. Divide both sides by negative 4, and we get x is 6. Very nicely done, right? Very nicely done indeed. Now I have my x. You have to remember, I need x and y. Does it matter which equation you plug it into? My suggestion is don't use one that you changed, like I changed this one by multiplying by 2. Use one of the originals, and it really doesn't matter. I'm going to pick the second one this time. So 2 times 6, because x is 6, plus 9y equals negative 15. So now we have 12 plus 9y equals negative 15. 9y subtract 12 equals negative 27. Divide by 9 and we get negative 3. Now it's very important you understand the solution to this system of equations. A system, remember, when I have 2 or more equations in there, that's a system. The solution is an ordered pair. My x and my y value written like that. So please get in the habit of writing those. Mr. Kelly definitely approves. Let's see what he can do over here with his watchful eye. All right, so let's see, Mr. Kelly, let's bring you to the front here. Okay, so as he watches us, ooh, very creepy. All right, so that was elimination. This time we're going to do substitution. I want you to see here the difference. 3x, the x's are aligned, the y's are in line, the numbers are in line, but the equal sign is not. This one's a good one to do substitution, and here's how you know when it's a good thing to do substitution. When you have one variable by itself equal to the rest of it, that's a great time to do substitution. So I'm going to rewrite this equation, but instead of x, I'm putting what x is equal to. So I'm going to do 3x plus 7y equals 10. But what is my x? My x is this whole thing, 2y plus 12. So now I'm going to solve that. So distribute here, that's 6y plus 36 plus 7y equals 10. I can combine like terms. I have 13y plus 36 equals 10. I need to subtract 36 from both sides. So that's negative 26, and I need to divide. So y equals negative 2. Now remember, I need to plug that in to find my x value. I have my y value, I need my x value. Now in this case, again, I can plug it into either one. It's going to give me the same one. I'm going to do it here because I already know it's solved for x. So x equals 2 times my y value of negative 2 plus 12. So x equals -4 plus 12, x equals +8. So again, I need to write that as my ordered pair of 8 and -2. Very good. Hopefully you remember substitution and elimination a little bit from Algebra 1. So right now I want you to try this one on your own. You decide what method you want to do best. You can do every single one of them with elimination or substitution. It doesn't matter. Some lend themselves better to elimination. This one, lined up nice and neat, it's probably better to eliminate. I'll give you a hint. You may have to multiply both equations by a number. So you try that one, pause the video, good luck. Alright, as you can see right here, I decided I want to do these numbers. They're a little bit smaller than here. So I knew that I could multiply this by the opposite. So I took 2, I multiplied it up here, but I only made it a negative. Because remember, I want the signs different. So I multiplied the first equation by -2. The second equation, then I multiplied by that number. It's an easy way to guarantee it, right? So this I multiplied by 3. So my two equations here, -24x minus 6y equals 12. 24x plus 6y equals -12. And you can see what happened was, boom, boom, everything canceled. So we need to talk about what does it mean when everything cancels. All right, so excuse me, Mr. Bean. Let's see what you watch over here. All right, so here we go. There are 3 types of solutions that you can have when we graph these. One is a ordered pair. So maybe I graph this line and I graph this line. And where they meet is my x and y. It's my ordered pair. That is my solution. So when I have one solution, I'm actually getting a number in here for my x, and I'm getting a number, could be the same, probably a different number for my y. So whenever you get an x equals a number or a y equals a number, you know you are on the right track to getting one solution, and one solution looks like that where they cross. We could also have a situation where, let's see, have me erase this real quick. We could have a situation where we have parallel lines. So maybe we have a line like this, and we have a line like this. Now those lines are never going to intersect. And since they never intersect, there's going to be no solution. All right? This happens when you get down to it and you get a false statement. Maybe 0 equals 4. All right? That is false. And when you get something that is false when you're solving, that means there's going to be no solution. And last, kind of tricky to see graphically, all right, is maybe you have a situation where you get a line and then you get the exact same line. That means every point on these lines are the same. And when we have that, we say that is infinitely many solutions. And when you'll know when you get that, because there will be no variables left, like no solution, but what will happen is you'll get a true statement. So 4 equals 4. That's true. All right, 8 equals 8. 0 equals 0. That's how you know when you have a infinitely many solutions. So over here we now know that we have infinitely many solutions because 0 does equal 0. That is a true statement. All right, so you need to keep an eye out on these. You could have one solution when you have 2 lines. All right, you could have infinitely many, or you could have no solutions. Okay, whoa, this one looks a little bit trickier now. We have a system of equations, 2 equations. One is linear and one is quadratic. Let's see how we go about solving this. Well, I'm going to use substitution because I have a variable by itself. So x plus y equals -2. And that y is x squared minus 4. So this is really now, I like to put them in the standard note, right? X squared plus x, let's add 2. All right, so -4 plus 2 gives us -2. Now we need to factor 2 numbers that multiply to -2 and add to 1. So that's -1 and +2, because -1 times 2 is -2, and -1 plus 2 is that. Got to use the zero product property, set these equal to 0. So I know x is 1 or x equals -2. So I have two answers. I need to check them both. I'm going to use this equation because it's solved for y. So let's plug in the first one. 1 squared minus 4 is 1 minus 4, which is negative 3. And then we have y equals negative 2 squared minus 4. Remember, negative 2 squared is a positive 4. So I have two answers. I have 1 comma negative 3 and negative 2 comma 0. Let's take a look and see what that actually means on the graph. So I'm going to try and do this graph as best I can. X squared minus 4. So 1, 2, 3, 4. Okay, so here we have our graph of our quadratic. All right, now let's just take, for example, let's just do something really quick and see what happens if I have a line. All right, before we plot our second line, let's just see what happens with the possibility of having a line. So I could have how many solutions now? I could have two solutions, as you can see here. I could also have how many solutions? I could have one solution, right? If it just meets right there at the tip, I could have one solution, okay? So there's a possibility of having 2, 1. We could even have 0 solutions. 0 solutions is also a possibility on this. Let's see what ours is. So this is the same equation as y equals negative x minus 2. So I'm going to start at negative 2, down 1 over 1, or up 1 over 1. And there are our answers. We got 2. Oh, and look at that. They just happen to match perfectly. So good. So good. All right, I want you to try this one. Take a second, pause the video, and try it on your own. Okay, so on this one, I plugged in here, I had x minus y, minus, this is very important. Now I put this in parentheses, this whole big thing goes in here. The reason I put in parentheses, I'm distributing a negative. So that was positive x squared plus x minus 19. I combined like terms, I got 2 x's, subtracted 80, I got negative 99. Two numbers that multiply to negative 99 and added 2 are 11 and negative 99. So when I use the zero product property, I got negative 11 and positive 9. I chose this second equation. It seemed a little bit less involved. I plugged in negative 11. I got negative 91. I plugged in 9, and I got negative 71. So if you want to pause and look at that, feel free to do so. Okay?
All right, ladies and gents, I'm cutting into this video because I want to show you how to work on these last couple problems using Desmos. Desmos is a graphing calculator online, so I want you guys to go to desmos.com. I don't know if you can split screen your video or not, but what we're going to do is we're going to solve these equations using a graphing calculator. And you will have that same opportunity on a quiz or a test or whatever using some of these problems. Some of them you're not going to have access to it, but Desmos can kind of help you understand some of these questions, especially since this one here is a cubed root and x squared. Okay, so cubed root is kind of hard for us right now in Algebra 2 honors. So, and Algebra 2 actually. So what we're going to do is I want you guys to go to desmos.com. So this is what appears on the right hand side. You're going to click on the right thing. It says graphing calculator. You're going to click on that. Now you got a graph and you have some stuff on the left where you can plug and chug. So what I'm going to do is I'm going to type in the first equation. All you do is type in the after the equal sign. Okay, so we got negative parentheses x minus 3 parentheses. Remember, squared is your 6 button. Shift and the number 6 gets you the exponent up, and then you scroll over and then plus 8. So that's an exponent of 2. That's quadratic. We've graphed these in the last unit. So you should already know how to graph that, right? The center is 3, 8. And then you go down 1 over 1, down 1 over 1, and then down 3, right? 1, 3, 5 rule. So then, okay, let's go on to the next one. The second side, I'm going to type in my second equation. So I get the third root. Now, how do I do the third root? I'm going to go down here to this show keypad. Okay, there's a lot of stuff here. All right, I want to go to functions, and I want to go down to over to miscellaneous, MISC, and I want to hit on the N root. Okay, so that gives you this button here, and we got to fill it in. So the 3 is what we call the index. We'll get to that in the next semester of this class. This is x plus 2, and then scroll over, and then -2. Okay, so what does that -2 do? Remember, even from quadratics, that just shifts it down 2. All right, so how do I actually solve this? I'm going to click this arrow here, and it's going to hide the equations so I can see the graph. When you solve these, okay, if you solve by hand, okay, remember, you know, you've set these equal to each other, right? So the third root of x plus 2 minus 2 equals negative x minus 3 squared plus 8. Now, what happens is this gets really difficult because I have to, you know, bring it over. I have to take either the cube root or the square out of there. It's going to be crazy. So that's why you're going to use a calculator. So how do we, on a calculator, on the graphing calculator by Desmos, do this one without solving it by hand? Well, what we're going to do is we're going to take our trusty mouse here, and we're going to click on one of the functions. I don't care if it's the blue or the red one, it doesn't matter. But what you're going to see, you are going to see the intersecting points, or the graphs intersect. You're going to see the graphs intersect. Okay, at 2 points. They intersect, let me draw a little bit here on my graph. Where we go? Okay, the graphs intersect at this point and this point. Okay, and there's, if you look out, there's 2 points over here, but you got to make sure you pick the right one. Okay, and I'll explain how to do that in a little bit. So this point, I got to figure out what this point is. Well, if I click on the point, it'll tell me. Okay, and if you have a problem of clicking on the point, what you can do is you can go up here to the plus and minus key, and you can zoom in. You click on the graph and hold it, and then you can move up. So I want to click and hold right there. That's my intersecting point right there. You see you have another point, but that's not a point that I want. I want the intersecting point. So if they intersect, that means the x value, right, is 0.0452. The y value is negative 0.7307. The ordered pair, right, is 0.0452, comma, negative 0.7307. So that's one solution. But you could see on the graph that if I now click and hold and bring it over, okay, you can see that they touch again. So if you touch on the function, okay, you're going to get the point at which they touch, which is 5.81. So another value is 5.831, and the y is negative 0.0142. So the other solution is going to be 5.831, comma, negative 0.0142. Okay? Here's what I want you guys to do. I want you to go ahead and do this one. Okay? Do this one on the calculator. All right? Absolute value, I'm going to tell you right now, here's where it is. If you go down to the show keypad, okay, you can get the absolute value right above the ABC button. Okay? The square root is also right there. Okay? If you need any higher roots, that's where you go to functions and miscellaneous and get the other one. All right? Pause the video, try these two, and then hit play.
Hello, it's me, Adele. Pause the video.
Okay, coming back here. I want to type these in to make sure you get the hang of typing these in. So this is the absolute value of x minus 4. So I'm going to go down and hit the keypad, hit the button above the ABC. Then I get x minus 4. I'm going to scroll out of that and then get plus 2.5. All right. I'm going to hit enter, go to the next line. And now square root button is already there. X plus 5. X plus 5. And then plus 3.1. Okay, I got both of these, so I'm going to click off of it and close it. And now I got to find my graph. So I'm going to zoom out. You can hit the plus and minus key. You can see those are my two functions. Okay, they touch twice. So you're going to have two solutions. Could you have 3 or more? Sure, you can have more than 1 solution or 2 solutions. You could have more than that. Okay, and I'm going to click on either the blue or the red graph. I'm going to find they touch in 2 places. 0.959, comma 5.541 is one, and I'm going to find the other one is 8.238, comma 6.738. And those are your 2 solutions for this systems of equations with absolute value and a square root function. Okay, that concludes this video, this lesson. Make sure in your homework or your practice, when it says using graphing calculator, you do go to Desmos. Okay, I would probably have that bookmarked. You might have already been there already this semester, but just letting you know, that's where you should go. You do technically have a TI calculator on your Chromebook, but it might or might not work depending upon when you watch this video. So, Desmos.com is always there. It is free. I suggest you go there. If you have questions, again, shoot an email to me, and we will figure it out. Other than that, deuces.